Good evening. This is M.Ashok Chakravarthy, Assistant Professor, Mechanical Engineering Department, JNTUACE College of Engineering, Anantapuramu. Today, I am going to explain the fabrication of solar robotic vacuum cleaner. And the project work has been carried out in our department. The abstract is smart solar dust collector. And nowadays, the use of solar vacuum cleaner can help us to reduce the pollution. Instead of using this smart solar robotic vacuum cleaner, if something else is used, then it may cause some pollution to the environment. So the use of vacuum cleaner will help us to reduce the pollution which is caused to the environment. By catching the sun's rays, that is solar radiation, dust may be collected more efficiently, which is benefiting to the environment. On the basis, the contents of this project work are thesis work are on the basis of Bernoulli's principle. Vacuum cleaners operate. This theory underlies the reduction of air pressure in vacuum pumps. Thus, when a porous material such as carpets is brought closer to the nozzle of this vacuum cleaner, the debris, that means the dust and the filth, are directed to travel inside through the intake, and there is less air pressure inside the vacuum than the outside. So the vacuum gets cleaned. So the suction volume is created inside this vacuum cleaner, and the dust, debris and filth are collected inside. The DC motor and the impeller are the main components of this robotic vacuum cleaner, and the ultrasonic sensor will help to detect the barriers, and it will send the signals to Arduino, which is a microprocessor. And also the robotic vacuum cleaner contains a 10-watt solar panel which is installed on the top of this vacuum cleaner, so as to collect the amount of sun rays and conversion of that solar rays into domestic power, with which in turn it is supplied to the battery in the converter and then utilized whenever it is required. And the other component is 12-volt DC battery supply. Next, the research objectives of this thesis work are: objective 1 is vacuum cleaner's purpose is to remove contaminated material like dust, fiber and threads from a surface to be cleaned using an airflow produced by the vacuum formed inside the device by an electrically powered vacuum generator or fan. So the vacuum is generated inside by using the vacuum generator or fan, which is rotating inside the vacuum cleaner. And the objective 2 is the solar vacuum cleaner is operated by using the solar energy. Solar energy collected on top of this vacuum cleaner, a PV panel is arranged, and that PV panel will collect the amount of power required for running of the vacuum cleaner. The novelty of the work is solar powered outdoor vacuum cleaner with a DC motor driven suction pump. A receptacle to contain the litter will be attached to the pump's exit. A battery that powers the DC motor will be charged by the solar panel positioned on top of the apparatus. It is possible to use to charge the battery in challenging circumstances. That means we can use this apparatus, we can use this robotic vacuum cleaner in remote areas where the normal power is not abundant and not readily available. For ease of movement of this vacuum cleaner, the entire machine is mounted on a trolley which is having wheels so that the movement of this vacuum cleaner is easy. Introduction and relevant study. The DC motor and the impeller is connected to the fan. A greater number of blades make up the impeller and therefore it is anchored above the frame stand, creating an airtight seal. The dust is removed from the ground by using a hose pipe. The dust is retained in a PVC plastic pipe that has been gathered. The machine will be taken to a dump site to unload the gathered dust. Two DC motors will assist in moving the machine to collect the dust particles when the voltage is applied to the equipment. The ultrasonic sensor will help to detect barriers and it will send signals to the Arduino, which is a microprocessor. Arduino is a microprocessor which will help to detect the batteries by sending the signals. After cleaning, the waste material which is collected is dumped out of the containers for the usage. According to the signals received from the ultrasonic sensors, the Arduino will control the vacuum pump. The vacuum pump is made up of impeller and DC motor. Materials and methodology applied here are as shown, like ultrasonic sensor, caster wheel, and a relay module, Arduino, and vacuum pump switch, and 12-volt DC supply. And the validation of the work is the area that may be swept in an hour is 27 meters square, assuming this machine moves in a straight line during 1 hour. The vehicle continues in a straight line until it comes across any obstructions in its route, such as room's wall or any pieces of equipment that are lying on the ground. When this robotic vacuum cleaner encounters a barrier, it will make a clockwise turn before continuing on a straight course. Coming to the results and discussion, this machine can function at a speed of 0.1 meters per second under typical operating circumstances, that is on a dry floor. And the hose pipe diameter is 75 mm. The hose pipe's area is 4,415 meters square, mm square. Area swept per second, or the area which is cleaned per second equals speed times pipe diameter, or 0.0075 meters square per second area is cleaned. The area that may be swept in an hour is 27 meters square, assuming this machine moves in a straight line during 1 hour. The vehicle continues in a straight line until it comes across any obstructions in its route, such as a room's wall or any pieces of equipment that are lying on the ground. When this robotic vacuum cleaner encounters a barrier, it will make a clockwise turn before continuing on a straight course. The ultrasonic sensor detection range is adjusted to be 20 centimeter. And the conclusion is the vacuum cleaner can comfortably sweep an area of 5 meter by 5 meter in 1 hour while using a minimal amount of power from its rechargeable batteries, which are installed on the vacuum cleaner's top. Through careful examination of each and every component, this project was developed to be inexpensive, affordable, and resource efficient. And the bibliography used is shown. It is Aslam Golami, Maghami, and we have gone through so much of research papers for carrying out this work. And thank you.